Okay, hello, welcome to a new video. I'm just going to be taking you guys through some of the hardest topics in each Atpl subject. First of all is altimetry and meteorology. This is probably the most daunting topic that you'll come to first in your Atpl studies. A lot of flight schools, including myself, do that in the first module, making it probably the first topic that you'll come to that will really be difficult. However, once you get to know the nuances and all the little things in the questions that the question writers give you to try and trick you up, you will be able to move on from those. You'll be able to get all the questions right. You'll be able to pick up nice easy marks in the exam. I ended up scoring 96% in my meteorology exam. Only dropped 3 marks, none of which being altimetry questions. Got 100% in those. So, like I said, nice easy marks, and you'll be thanking the examiners for giving you them, because it saves you quite a bit of time as well. You can do it quite quickly once you get to grasp of this topic, which I'll be giving you shortly. So first of all, I'm just going to break down some basic definitions for you guys. As always, these are in red, so these are probably ones you'll have to learn. Again, just learn them, you'll see them, and move on from that. You see them quite often, so you will get used to them. So first of all, you've got QFE. Now QFE, as it says, FE, so that's height above the field elevation. So that'll be the pressure setting that you set on your altimeter in the aircraft, and it will give your exact height above the airfield elevation, as it says. Your QNH, on the other hand, is the one you'll probably be flying with most of the time. That gives you height above mean sea level. So that's a difference. So when you land using QNH, you won't actually get a reading of 0. You'll get a reading of whatever the aircraft is above mean sea level. However, when you land using QNH, you will read 0 because you're 0 feet above the airfield elevation. SPS is another thing that you're going to have to be comfortable with. It's a standard pressure setting. Nowadays in Europe, we use 1013 hectopascals, and in the US, you might use 229.92 inches of mercury. However, it's 1013 for us. We'll also have to get used to hearing transition altitude and transition level. So transition altitude is an altitude, so that's when we're climbing from an altitude and we're transitioning to a flight level. And transition level is opposite, so as you're descending, you're transitioning from a flight level to an altitude. Usually these are about 7,000 feet, maybe 6 or 5 in Europe, depending on different factors. But they will be stated in the question. And so when we're going from transition altitude, we're transitioning from the local QNH up to 1013. And when we're transitioning below to the transition level, we're going from 1013 down to the local QNH, so flight level to an altitude. So now we're starting to get into the real gritty stuff of altimetry. So what I've got on the board here is the formula or the process in which my flight school has taught us to do it. It's called PT-PIT. So you'll notice that the letters are in bold, and that's how we remember it. That's how you write it out at the start of your exam, and you'll remember it from that. So starting on the bottom row, we've got our pressure altitude. Now, pressure altitude, as I mentioned, is using SPS. So it's using our standard pressure setting, and it's going to be a flight level. So whenever in the question you get flight level, it's going to be our pressure altitude. That will be using 1013 hectopascals, as I said. Next is your I, your indicated altitude. So that's what the pilots will see on the altimeter and inside the aircraft. Often this is going to be set using the local QNH. So I'll talk more about pressure correction in a second. And next also is your true altitude. So your true altitude is what the aircraft is actually above mean sea level. You notice we have temperature error correction here. So temperature error correction is based on your altimeter never always indicating the correct altitude. It will always be slightly off unless conditions in the atmosphere are absolutely perfect. So that's why our indicated and our true altitudes are different values. So we're going to want to convert between these, and it's obviously it's just a converting game most of the time. A lot of the time they'll just give you a pressure altitude and they'll say, give me a true altitude, and that's it. You just got to convert. So we're going to go through the steps of how to convert between the altitudes here. So pressure altitude to indicated altitude, as it's mentioned here, is going to be your pressure correction. So pressure correction just means we're going to correct from 1013, which is what we use for a pressure altitude, to whatever the local QNH is. So that may be 1013, but often it's not. So I'll speak on how to do that later, but just that's what the P means. So it's our pressure correction. And next to that, we have our temperature correction. So our temperature correction is going to correct between indicated and true altitude. This is because, like I said, our altimeter never is really spot on unless we actually use perfect iso-atmosphere conditions. Therefore, the temperature induces some sorts of errors in our altimeter, and we use a formula to calculate this error coming later. So that's the basis of what we're going to be doing to convert. Note this down, get this in your head. I'm sure after a while it'll all become second nature, but that's what we use at my flight school, and this is probably the best way to go between it. Like I said, learn what all these are, be familiar with them. I'll go through them in a bit more detail in the coming slides, but have a note of that down. It's quite important to know. So like I said, I'm going to go through the different ways in which we convert between the altitudes. So as I mentioned, the first correction we'll come to is our pressure correction. That's the P up here. So we're going to start with this conversion. So from our pressure altitude to our indicated altitude, and we do that by pressure correction, as I mentioned. So here's an example question that we've got. We're at flight level 150 and we're looking to turn that into an indicated altitude. So as I said, our flight level 150 is a pressure altitude, and we're looking to turn it into an indicated. So we're going to use pressure correction. It's given us the local QNH of 1018. However, you may be thinking, where is the flight level QNH? That's just something you'll have to know, and it's 1013. Like I said, it's going to be done so many times that it will just remain in your brain forever. So that's our pressure altitude QNH, and the local QNH is 1018. So this is the way we're going to set it out initially. We're going to say pressure altitude, so we're at 1013 hectopascals, is equal to 15,000 feet at level 150. Okay, so 1013 is equal to 15,000 feet. Local is 1018 is equal to something, and that's what we're going to figure out. That's what I'm going to show you how to figure out. So we set it out like this. It gives a clear indication of what the two QNHs are and what the two altitudes are. Obviously, that one is not just known yet. So to convert between these, we're going to use 30 feet per hectopascal. That's a basic one. Some people say 30, some people say 27. It may mention in the question. Just beware that you might not get spot on values if you're using 30 or 27 based on what the question actually uses in its own answer. So you may be 10s or 20s altitude off in your real answer. However, that's all taken into account. If they ever want you to type it in, it will be known. However, if it's a multiple choice, you'll just pick nearest answer. So as we can see between the two values, 1013 and 1018, we have a difference of 5 hectopascals. That's just minusing them, that's all. We find that we have a difference of 5. Therefore, since we have 30 feet per every 1 hectopascal, for 5 hectopascals, we will have 150 feet. So that means all it is going to be 150 feet difference between the altitudes. Which way? I'm going to tell you how to figure it out now. So we use a saying called wind up, wind down, wind down. So that means when we wind up our altimeter setting, i.e. from 1013, we wind it up to a higher number, 1018. That means the altitude also winds up as well. So as we increase the number in the QNH setting, the altitude also increases. So we're going to be at a higher altitude by 150 feet, sorry. So we're going to wind up, we're going to increase our altitude by how much? And that's the difference in hectopascals, which is 150 feet. Therefore, as I said, winding up, we wind up and add on to our altitude. So it's just going to be 15,000 plus 150, giving you 15,150 feet. Nice and simple. So we look for the difference. We find using our conversion the difference in feet. We figure out whether we're going to be winding up the altitude or winding down. And then we add or minus on the altitude. That tells us how to get our indicated altitude. Next, we're going to find how to get our true altitude. So our true altitude is going to be the second part of this, and we're converting from indicated, which we just got before, using our temperature error correction to true. So we've got a question here on the board. Turn 12,000 feet indicated into a true altitude. The local temperature is 20 degrees Celsius measured at sea level. Okay, so that's nice and simple. We've got our indicated. It wants us to get a true, and we're going to have to use the temperature error correction to do so. So the formula here in purple is the one that we're going to have to memorize. Formula here in purple is going to be used so many times, it's going to be ingrained in your brain. Temperature error correction is equal to 4 times by the isodeviation times by the layers. So for anyone who's not familiar with that isodeviation, I'd have a search of that now before you come back to this video, and we'll go through it again. So the temperature error correction being 4 times isodeviation times layers in 1000s. So if you had, for example, a 5,000 feet layer, that would just be 5. This is probably the bit that people struggle with, the layers. So I'm just going to go through it quickly now. The layers are going to be the difference between the aircraft and wherever the temperature is measured from. So a lot of the time, people say that they get mixed up between the mean sea level and the fact that it might be from an aerodrome. So sometimes you'll get the temperature being measured at an aerodrome 5,000 feet above sea level. So you will have to use that as your lower point instead of 0. So for example, if the aircraft was at 10,000 feet and the temperature was being measured from a station at 5,000 feet, like I said, the difference in layers in that would be 5,000 feet worth of layers, and in thousands that will be 5. So like we got here, we got temperature error correction, just filling in the formula here. So we got 4 times the isodeviation, so that's 20 degrees Celsius. So 5 degrees isodeviation difference from 15. So 20 minus 15 to find the difference there, times the layers. So the local temperature was measured at mean sea level. So that means we can take the altitude. So the difference between our layers is aircraft and wherever the temperature measured from. So the difference between our aircraft at 12,000, mean sea level, which is where the temperature was measured from, being 12,000 feet. So the layers in thousands would be 12. So just simplifying that formula there, we get 4 times 5 times 12, giving us a temperature error correction of 240 feet. Now, this is the tricky part. Do we add or do we minus that off of our 12,000 indicated? Here's how we're going to be able to do it. So these are two sort of slogans you can use, low high and high low, simply the opposites. So this means low high, meaning whenever the temperature is lower than ISA, our altimeter is high, so it overreads the altitude. Whenever our temperature is higher than ISA, the altimeter is low. So when the altimeter is either high or low, let's go with high. When the altimeter is high, the indicated altitude is bigger than the true. So you're reading an altitude on your altimeter that's bigger, i.e. overreading your true altitude. When it's low, this number is going to be less than your true altitude, and that's going to be higher. Okay, so in this situation, we're 20 degrees Celsius, so we're going to be above ISA temperature, so above 15 degrees. Therefore, we're looking at this, looking at high, low. So we're high, so our altimeter is low, so our altimeter underreads, so therefore our true altitude is going to be the bigger number. Our true altitude is going to be bigger by this amount, by the amount that we've just figured out. So therefore, since the temperature is above ISA, our altimeter overreads and our indicated altitude is higher than true. As a result, we'll add on the 240 to give us an answer being 12,240 feet. So we're finding the difference using our temperature correction formula, finding out whether to add it or minus it using our low high or high low, and then we're adding or minusing it on accordingly. So here we've got a basic example. Feel free to go through this on your own if you're comfortable at the moment. I will be going through this in just a second, but feel free to pause and have a go of this, note an answer down, and we'll see how it compares to my own. So let's go through the question. Given the local QNH is 1004, temperature measured at 2000 feet is 9 degrees Celsius. What is the indicated and the true altitude of the aircraft flying at flight level 190? Okay, so first of all, let's start with the indicated altitude. Again, going back to our PT pit, we know that to convert between pressure and indicated, all we need to do is a pressure correction. So I've gone through this here. And we've written out as we should. Find the difference between the 2 hectopascals, times it by our 30 feet. Figured out, do we wind up, do we wind down? In this case, winding down to get 1004. Therefore, our altitude winds down by how much? By that amount there. So we minus it and get 18,730 feet indicated altitude. Perfect. That's 4 marks and 1 question already done. Let's move on to the true altitude part of this question. Moving on to the true altitude segment. So as we mentioned before, with PT pit to convert between indicated altitude and true altitude, we need to do a bit of a difficult one. We need to do a temperature correction. So that's what I've done here. We've got our answer from the previous stage, and we've had a look at the temperature correction formula here, noting it down as first as usual, and then filling in what we have. So our temperature being 9 degrees Celsius, and this is a tricky part here. Since the temperature was measured at 2000 feet, that's where we're going to use. So we're going to use 2000 feet as our lower altitude to measure the layers between. So we got the amount of layers between our altitude of our aircraft indicated at 18,730 minus the altitude indicated for our temperature, so 2000 where it's measured, over 1000 to get it in layers in thousands. So it's going to be 4 times 6 times that answer right there, 16.73, which is just our formula, giving us a temperature correction of 401.52 feet. Again, like I said, if this is multiple choice, it will be obviously the closest answer, but if it is not, then it will give you exact values to use, and probably nicer numbers than I have here. So we're going to figure out whether we add or minus it. Temperature being lower than ISA, we're going to use low-high. So low-high means our indicated is higher than our true. So our true altitude is lower. That means we're going to minus it off, and we're going to get 18,328.48. Like I said, any answer around 18,300 perhaps will give you the right true answer in the real exam. Okay. So here we've got just the example of everyone's favourite question database, Atpl. This is a bit of a harder question. However, this is the sort of question you'll be getting in the exam. Often they like you to do the conversions and find a true altitude, and then they want you to use that. They want you to use it maybe to find terrain separation. They maybe want you to convert from a true altitude back to an indicated altitude, and back to a pressure altitude to find a minimum flight level maybe. But in this case here, we're going to be using our pressure altitude there, finding the approximate terrain separation. So we're going to be finding from the pressure altitude, we're going to find whatever true altitude we're at. And then we're going to use that and compare it to the terrain height, which is 2,320 feet. And we're going to use that to find out our terrain separation using our true and known terrain heights, which I'll be doing in just a second. So quickly rattling through this, we have our flight level 50, i.e. 5,000 feet is our pressure altitude. We're going to do our pressure correction here, figuring out the difference between our 2 altimeter settings, times that by 30 to find our difference in feet, using wind down to find the difference, what we're going to do with that difference, and we're going to be minusing it since we're winding down, to give us an indicated altitude of 3,980 feet. Great, first part done. However, that's not going to get us our answer. We need to find our true altitude to get the answer. So like I said, to find the true altitude, we're going to do our temperature error correction. So temperature error formula being 4 times standard deviation times layers in 1,000s. So we've got our 4. Now this is a bit difficult because it's a minus 10. So the ISO deviation between 15 minus 10 is actually 15 plus 10. So it's 25 degrees different from ISO. So you could just think about that in your head. You don't need to do a particularly hard calculation on your calculator. It's what's the difference between this and 15 plus 15 degrees, which would be 25, as we said. Now we're going to use our indicated altitude, and we're going to minus it from the altitude which the airport is at, as that's where we measured all this data, so the temperature at the airport. So since we've measured the data at 1,600 feet, that's going to be the lower end of our layers. The upper end is going to be the altitude of the aircraft, and again we divide that by 1,000 to get it into layers. Again, the formula being used here, just running through calculations here, you guys can do it on the calculator as well, giving us a temperature error correction of 238 feet. Now with the temperature being substantially lower than ISO, it's pretty obvious we're going to use low-high here. So low-high means our altimeter indicated is higher, so altimeter will overread, so our indicated will be higher than true. Therefore true is lower, and to find true, we're going to minus our temperature correction. So our altitude in true being 3,742 feet. So we're nearly there. 3,742 feet true altitude, but it's asking us to determine the approximate minimum terrain separation. So the approximate minimum terrain separation is going to be using the data we have here. So highest terrain is 2,320 feet. That's our altitude. We're going to find the difference and get an answer of 1,422 feet. Going back to the questions options, we can see that we've got the closest answer right there. Like I said, it's not always going to be absolutely spot on, but the closest answer will be correct. Quite often the UK are moving a lot to typing questions, so it'll be asking you to type in the answer. Makes it a bit more difficult for you guys. However, they will be required to give you more precise data, so they'll be required to give you examples. For example, where we use 30 feet, they'll be required to give you 27 or 30 as you are typing that in, or it will be given as a range of answers. So you'll be allowed a moderate range between a few answers, and they'll mark it correctly if it's in that range. So like I said, multiple choice is the closest, or use the figures that they've given you if it's going to be a typing in your exam. So in summary, you're going to go away, you're going to learn the method first of all. Learning the method, PT Pit, will save you so much time in the exam. You'll be able to easily recall it, easily recall all the formulas, easily recall all the numbers that you'll need, and it will just be your friend. PT Pit is the way to go. It's probably the easiest one, and it never let me down for a single altimetry question, so I stand by it. Next, you're going to practice on ATPLQ, practice on your internal database, whatever you have access to questions, do them. You should be pretty much finishing the bank by the time you get to your exam. It doesn't matter if you haven't done all of it, as long as you're comfortable with what you're doing. It's all about knowing the tricks that the examiners are going to use, because ultimately you will get it wrong. You'll get a lot wrong, and you will see a whole lot of red in your first few tries going through the database. And that's okay, because what you're going to do is you're going to learn the tricks that the examiners are going to give you. They're going to hide little things in the questions, little nuances, often with the layers in your temperature correction, or sometimes with the numbers that they're going to use. They're going to try and trip you up any way they can, just to separate the people who have actually put the work in versus the people who just rock up to the exam and think they're going to be fine. Because you are going to put the work in, and like I said, you are going to be fine. The next step is just to get it right in the exam. Easier said than done, but once you practice many of these, you should be getting them as a piece of cake in the exam. There are new questions being introduced every day, so be aware that there won't be carbon copies from what you see in the bank quite often. However, like I said, they changed the numbers out a lot, so it shouldn't be memorizing of the answers. It should more be memorizing of the method and how we do it. But once you've taken a lot of practice into it, you should be fine. So yeah, that was a quick summary of altimetry. If you would like to see any other topics mentioned in this series, please do leave them in the comments below. If you have any questions on this video, again, leave it in the comments below as well. Sorry for the break. It's been quite a hectic few months recently. Starting a flight school is not easy, so I've been focusing on the exams. However, I've got a little bit of time off, so I thought I'd give you a bit of a rundown on some of the subjects. So yeah, thanks for watching, guys, and I will see you in the next one.